Hi and welcome to Win the Race with MySQL HeatWave Lakehouse. In this session we're going to cover how you can get started with MySQL HeatWave Lakehouse, and I'm going to use it to analyze data from SailGP. So that's a fairly new sport, but a very exciting sport with a lot of data to analyze. And I think that makes it a very good example for us to demonstrate what's possible with the Lakehouse technology. So we're going to go through all of the typical stuff you would do when you have an analytical challenge. Right? We're going to load data into object storage and link it with MySQL. We're going to hook up a visualization tool and use that to look for insights. And we're also going to use it to build our own machine learning model. So I'm going to demonstrate all of those things. So let's try to help these sailors with their data as well as we can. And set sail.
8 boats with the world's best sailors. A beautiful day and a fast racetrack. It is going to be on today.
Nation versus nation. These super high-tech boats, iconic venues all around the world. It's frankly the most exciting thing I think that's happened in sailing for perhaps ever.
It's all about speed and tactics. No room for error on this stadium course.
I think technology allows us to make smarter decisions.
We have sensors on pretty much every part of the boat. The cool part about uploading it all to the Oracle Cloud is that anyone can access it from anywhere, anytime.
Every team can see it, so there's things we can't hide.
Having the access to the data really helps us fast track that learning.
Any time that we're advancing the technology, we're really looking at data. I think we're all really excited. This is definitely the next generation of high-speed foiling catamarans.
So my name is Jeroen Kloosterman. I work for Oracle in the product strategy team. I've been working with data warehousing with machine learning and AI for the last 10 years or so. And it's really my pleasure to talk to you about a subject like MySQL HeatWave Lakehouse. Now behind the scenes we have Karsten Thalmeijer. Karsten is a solution engineer in the MySQL and HeatWave team. And he's got a wealth of experience also with these products. So he's also online here to help you with any questions you may have along the way. Before we dive into a demonstration of MySQL HeatWave Lakehouse, let's talk a little bit about SailGP itself. So we've brought up the website here of SailGP, and what it's really about is that you have these countries sailing against each other in locations all over the world. And what makes the sport so special is the technology that goes on with it. So these boats, we call them boats, but they really should be called machines. They're just so high tech, and they've got a very high sail of 24 meters, giving them a lot of thrust, and they can lift themselves out of the water in foil, as it's called. So they literally fly over the water at incredible and sometimes dangerous speeds. Now, what else is important for us to know is that there's a lot of sensors on board of all of these boats. So sensors that measure things like the wind speed, the tension on the sails, the distance to the water, you name it, right? There's a sensor for it, literally hundreds of sensors. And you can imagine that collects a lot of data, and all of the data we want to be analyzing. It can be gigabytes of data for every race. So this is where MySQL HeatWave Lakehouse comes in. The teams, or the people sailing the boats, they're trying to make sense of all that data, and they want to use the data to better understand what's happening with the boats while they're sailing it, and hopefully, of course, get an edge over the competition. So today, that's our goal, right? We want to help them with that data and analyze their data. Okay, so what's the format? Today, everything is a demonstration. You don't have to do anything. But I do want to say that if you feel intrigued and you want to do all these things yourself, you can, right? So you can get a trial for Oracle Cloud Infrastructure, and everything you see today is available in a workshop. We call that a live lab. So all the steps are in there, all the detailed steps of how to set up the services and how to do the analysis, etc. You find all of that in the live lab. So you do have the possibility to repeat what you see today yourself and try out the technology. Okay, so now let's really get started and get to the agenda. So first of all, we're going to focus on the Lakehouse aspects, right? And that means that the data that we're going to be using, all of this sensor data, we're going to load it into object storage, so not into the database itself, right? We're not going to persist the data there. And I'll explain in a little bit, what the advantages are of doing that. But first of all, we're going to load the data. Next, we want to do some analysis on the data. And there we're going to take more a perspective of a non-technical user. So we're going to use Oracle Analytics Cloud to look for some insights. And it could have been another tool as well. But OAC and HeatWave Lakehouse, they work really well together. So that's what we'll use in this session. And last of all, we have a particular challenge also in SailGP that requires machine learning. So we're going to use AutoML of MySQL HeatWave Lakehouse to build our own machine learning model. Okay, so let's start and go to this first phase of the data loading. And I've already provisioned MySQL HeatWave Lakehouse. We're not going to go through all of that. That's already ready to go. So we can start off this point where we're going to upload this file. And we are currently here in the OCI console and we're looking at object storage. Okay, so in this particular bucket, SailGP, I've uploaded a number of files. And the particular file that we're interested in now is this one, SailGP SDP Stream Pivot Extract, and it's about 1 gigabyte in size. Okay, so before we actually start loading or linking to this data, let's talk for just a second why we're using object storage here. What is the benefit of using the Lakehouse approach? And if you think about the company that organizes SailGP, they probably already have a database, right? They have a database for back office data, let's say their goal data, maybe on the races, like where the races are being held and what date, the competition, the rankings during the race. Yeah, they're trusted golden data. Now if you take then sensor data, that's a really, really different category of data, right? It's kind of more external. They might not want to mix that data with their back office data. So that's one reason. But the second reason, maybe even more important, has to do with the format that the sensor data comes in. Because right now, maybe we have 200 sensors in this CSV file that we receive. But it's quite possible that next week, these boats are changed and we add 10 sensors more. Now that is a problem if you load your data in the database. If you were to do that, you create a data loading process, then you would have to update that data loading process and you'd have to do that several times, which is not ideal, right? That is not very efficient. So here are the benefits of the Lakehouse. It's not so strict on that format. And we don't have to define that format in advance. We can include additional data, let's say third-party data very easily, or even enrich our base data with additional data like the sensor information. And it's very good for things like experimentation. Okay, so now let's come back to the object storage. And what we now need to do is we just need to tell MySQL where it can find this file, right? So we can query it as if it was just another table. So how do we do that? Well, for that we first need to log into the MySQL shell. So I've already got that installed on a compute instance as well. That's here on this machine. And I already have the command of starting the MySQL shell ready to go. So let's just open that. And now we want to fire off the command that will link to this data set on object storage. Okay. So how does that? Well, let's first have a look actually at the data set itself for you to understand it. So the data set looks like this. And it's important to understand that every record in this data set is 1 second for one boat in the race. Okay, so if you take the first record, this for the first race for second 607 for the USA boat And then the rest of the columns are just all of the possible sensor values, right? All the values for those sensors. So with this, we can track the state of the boat and all the sensor values for each boat throughout all of the races. Okay, so that's the data set, and that can get fairly big, as you can imagine. So how do we instruct MySQL that this file is there and that we want to use it? For that we need this command, and I'm going to just open that here. So we're going to use sys.heatwave_load, okay, to set up an external table. And it looks maybe a little bit cryptic because there's like this piece of JSON going on here. So it looks complicated, but really it isn't. You just have to replace the key bits of information. And those key bits are, first of all, what is going to be my target external table? How do I want to name that, right? So I've just said I've given the same name as the data set, the file. And I've added a tool here as well because I already did this morning. I don't want to overwrite that work. And also, yeah, well, here's just some basic parameters, but this is the key bit. This is the link to the file on object storage. Okay, so we need to point to this, of course. That's where it can find all of the data, right? And by the way, you can get that if you are in object storage. You can say create pre-authenticated request, par file. So that's where you get the URL. And again, I've already done that. So yeah, this command is basically ready to go. Okay, so I'm going to take it. And I'm just going to paste that in the SQL shell here. Okay, so there we go. And so I think maybe the most interesting thing about this command is actually what you don't see in there. Okay, so let me just scroll up a little bit here. So notice how we don't see anything about column names or column types, right? We are not specifying that. And that's very handy, because imagine if we would have to do that, that would kind of defeat the whole objective, right? Of being free with our format and not having to specify that ourselves. This is much faster, of course, and it also allows us to adapt to changing data much easier. Okay, so we don't have to specify that ourselves. Those column names and data types are automatically derived. Now, what you also don't see here is any information about performance or things like indexes, right? I'm not saying to MySQL HeatWave Lakehouse, you should use this and this columns and create an index on it so the querying can be faster. That also doesn't have to be done by the user, because that's done automatically right at this moment. The HeatWave is going through the process of, first of all, finding those columns itself, finding the data types, and also it's profiling the data and gathering the statistics of how the data is distributed. And that's going to be key in later running those queries on this data set really fast. Okay, so let's see how far it is. Yeah, and in this case it's already finished loading that. So it took almost 30 seconds here. And again, this data is not loaded or persisted into MySQL database, right? It is linked to it, right? And it gets loaded dynamically from the object storage into memory directly, right? So that's very important to understand. So now let's see what we've got in this table, right? We can now just simply say select count star from sailgp.sailgp sgp string pivot 2. Okay, and we see we've got 1.6 million records. Also, let's see what is now the DDL, or let's say the definition of this table. So we're going to say show, what is it? Show create table, sailgp sgp string pivot 2. Okay, And we see, this is the great thing, we didn't have to do this ourselves. We got all of these column names, which it got from the first file in the first line in the CSV file, and also the data type has automatically been derived because it's been doing this inspection of the data in the CSV, right? So that saves us a lot of time, okay? All right, so that's done. At this point, our data set is ready, right? So we could run SQL on this data set or on this table right now just as if it's any other table. So the complexity behind that this is actually an object storage and not in the database, that is all handled by MySQL itself, right? So you don't have to worry about that. Now we could run any SQL here right now, but we're not going to do that because in the next step we're actually going to use Oracle Analytics Cloud to do some analysis and to try to find some insights. So let's go to that next step. Okay, so in this second part we're also going to switch roles because this kind of work doesn't require MySQL skills, right? This can be done by the sailing performance analyst, I mean not a technical MySQL user. So let's go into OAC, and the first thing we need to do is create that connection between OAC and MySQL HeatWave Lakehouse. So I've already done that, and let's look at that connection here. So when you create the MySQL HeatWave Lakehouse instance, you're gonna get this technical information on the endpoint and how you can reach it. And basically we're copying in that information here in the dialog, also with the username and the password, and that's it. Basically then you're set up and you can connect. So I'm drilling into that connection now, and what that allows me to do is look at all the table names that exist in MySQL HeatWave Lakehouse, and it doesn't matter whether those are the physical tables, right, or external tables. We can see all of them. In fact, OAC doesn't know the difference, of course. And what's happening now is that OAC is doing some data profiling of its own. So it's looking at all the possible values in each of these columns and creating this kind of mini charts that quickly tell us what's going on and what kind of data is available. That's of course really useful in this data lakehouse situation when we get data from some external source and we're trying to understand what's going on and how useful it is for us, right? So for example, here we see immediately that we've got 8 teams available to us that we can analyze. We see immediately in this particular attribute the length RH bow, which is the distance of the boat to the water, what kind of values are in there. It's from about -1 to +2, right? So this appears to be in meters, right? We see, for example, the true wind angle here. It is between -180 and +180. So yeah, that tells me this is in degrees. It's not in radians or something like that, okay? So you might also see here that some columns are empty and you know straight away, okay, I can't analyze those, right? So this is very interesting if you want to have a quick idea of what can I even do with this data set. Right, so let's say we've connected this data set up to OAC, okay? How now can we ask some questions about this data? How can we get some answers to our questions? So we're gonna zoom in on this particular data set, and let's say my question now is, who won a particular race? Okay, so I'm gonna take the race ID, we're gonna zoom in on race ID 1, and I'm gonna drag in the team name, right? That's in the column B name, and again we see 8 team names. So to see who has won, my idea is now to take the time sailed, because time sailed indicates how long it took them to do the race, right? So the lowest value here indicates that you finished faster. So let's display this a little bit nicer in a bar chart. Let's sort this as well. Time sailed, low to high. And we see Great Britain finished the race already in 734 seconds. So they won the race. And that's how easy it can be to drag together, let's say, an answer to a question that you have, right? Without knowing SQL, of course. So let's take a different question. And my question in this case is, which team had the highest maximum speed during the race? Okay, so I'm going to duplicate the chart. And instead of using time sailed, I'm going to use boat speed knots. So I'm going to replace that value here. And in this case, let's sort it from high to low. Okay. And again, the answer is Great Britain. So they reached a maximum speed of 15.9 knots. That is 94 kilometers per hour. So that's very impressive. And in fact, we're going to have a look at a video fragment of when this happened.
And this will be a critical point in the race. They talked about the high winds and how tricky it is.
This turning mark's going to be absolutely crucial. Sir Ben Ainsley, well, he needs a big first race, and there's nothing better than being in the lead at mark number 1. 93, that's 94 kilometers an hour as they round mark 1. Incredible speeds there, over 50 knots.
Okay, so a very impressive speed by Great Britain, but have you also noticed the speed of the queries here in OAC? And of course, the powerhouse that makes that all possible is MySQL HeatWave Lakehouse, right? So the Lakehouse is able to go through that 1 gigabyte of data that we uploaded and choose the optimal type of query, how to go through and navigate all of this data and give us the best possible response, regardless of where the data is, if it's in the object storage or in MySQL itself. Okay, so next, we're changing gear a little bit and we're going to investigate the maneuvers of the sailing boats. So when a sailing boat wants to go in a certain direction, you know it doesn't go straight, right? It goes into zigzag motion. And the reason it does that, it wants to take maximum advantage of the wind. So when they do this zigzag, when they change direction or they go through the wind, they make a maneuver, right? They change direction. And in the quality of how they do these maneuvers, that often decides the winners or the losers of the race. So that is really important, and we're going to investigate how well the teams are doing that. But first, let's have a look at a short video about how these teams make their maneuvers.
So the first thing that happens is the helmsman or someone will say stand by, and that's the cue for people to run across to the other side of the boat to operate the functions that are required on the other side of the boat. As the wing trimmer, for me, I'm steering, I'm lifting a daggerboard, I'm easing the jib, and for the person crossing at the front, one of the grinders, they're on standby to trim the wing immediately out of the maneuver and also to change the wing angle, so swap it from being cambered one way to cambered the other so it can catch the wind on the other side. And then immediately from that moment onwards, there's a flight controller that's flying the boat on all 4 foils, so the 2 daggerboards and the 2 rudders at the back of the boat. And at that point, the helm is turning the boat very, very fast. The faster they turn and the quicker they're able to turn after the daggerboard hits the water, the less speed is lost as we go through the turn. Then we exit the maneuver. The next thing is that the daggerboard gets raised, and at the same time the crew cross the boat, the helmsman takes the wheel, and then the maneuver is complete.
Okay, so let's investigate how the teams do these maneuvers. And the idea is, of course, the less they hit the water, the better they do it, right? You want to keep these boats foiling, and you want to keep them having the speed without touching the water during the maneuvers. So for that, I've already created a workbook here, the maneuver analysis. So let's have a look at what we've got here. And well, the first thing is a bit of a geographical analysis. And the reason we can do that is that, remember, we have all these sensor values in the data set. Well, we also have a latitude and a longitude in that same data set. So that allows us to basically track where these boats are at any moment in time. And with OAC, we can visualize that. So if we zoom out here a little bit, I'm not sure if any of you recognizes Hamilton, but this is in Bermuda. Okay, so that's where the race is taking place. And have a look with me how we compare the performance of the winner of the race, Great Britain, with France. Okay, so Great Britain in red here it makes, for one particular leg or one part of the race, it makes 1, 2, 3 maneuvers. And then France, the legger of the race, they made 1, 2, 3, 4 maneuvers. And that's of course already an important lesson, because generally speaking you want to plan your approach so you need as few maneuvers as possible, right? So that's already one possible, very interesting insight. Now the next thing we're going to look at is that distance to the water that I described. So what you see here are 2 maneuvers by France here in black and 2 maneuvers by Great Britain here. So here in red, and let me also zoom in here. Yeah. And what you see right now on the chart is just the angle to the wind. So you see right in the middle of the maneuver they go through the wind, right? So that's obvious. So what happens now with the distance to the water? And for that I'm going to drag in this column, length RH bow meters, I think this means, or millimeters. So we're going to drag that onto here, and we see that now in the chart as well. So notice, by the way, I've added this reference line at 0.3 meter. So that, I mean, the water line is 0 meters, but I think this means is that you have these little waves on top of the water, right? So that's why we have that value there. And notice how France is actually hitting the water in several occasions during the maneuver. And that of course isn't good, because then you can easily lose the foiling and you lose the speed. So that happens in both of the maneuvers. Whereas Great Britain, it doesn't happen to Great Britain, right? So yeah, that is probably one of the reasons that they won the race. And that's also an important insight for France here, something they can work on. Right, so in this case, we found some important lessons for France. So yeah, hopefully they can improve their game here. But in general, by connecting an analytical tool like this, like OAC, to MySQL HeatWave Lakehouse, that will help your end users to really understand data. It helps them to play with data and without having technical skills. Okay, so that's really important. And yeah, that helps us get the most out of MySQL HeatWave Lakehouse. Okay guys, so now we're getting to the third challenge, and we're going to use machine learning to solve this. So the challenge is, we're trying to help the sailors decide on the best possible sailing direction. So imagine he wants to go to a certain mark, a certain destination. What is the best angle to take relative to the wind to get to that point as fast as possible? So let's analyze that a little bit further. So here you have such a sailor. You can see he can choose between various angles relative to the wind. He can take a more narrow angle or a wider angle. And depending on that choice, he will either go faster or slower with the boat, but he'll also have more distance to cover or less distance to cover. And depending on all of that, he will get to his destination faster or slower. So what is the optimum angle? That's what we're trying to find out. So let's say the boat is here in the origin and the boat tries to get to the destination. And for simplicity we'll say, you see these arrows here at the top, that the wind is coming exactly from the direction of where we're trying to go. So obviously we can't go straight upwind, that's physically impossible, and the sailor will need to choose some kind of angle. So let's say the sailor chooses wind angle 1, indicated in blue here. This will result in a certain speed of the boat, right? And the speed of the boat you can see by the length of this green line. Okay, so that indicates how fast he goes as a result of choosing that angle and having a certain wind speed. But the sailor could also choose this wider angle to the wind, which in this case results to a higher boat speed. That's often the case if you choose a wider angle to the wind. But the boat goes faster, but he also has more distance to cover. So in this case, actually, the distance is longer, but the boat is so much faster that he will still reach the destination faster. And then there's also a third situation where we can take an even wider angle So in this situation, the boat goes really, really fast, but the distance becomes so long that even though you have this high speed, you still reach the destination slower. So somewhere in the middle here, between these green lines, there must be an optimum angle. So what we are trying to do to choose that optimal angle is we would like to know in advance what would be the resulting boat speed if we were to choose a certain angle. Okay, so we're interested to know the relationship between the wind angle, the wind speed, and the resulting boat speed. So that sounds pretty simple, and you think, oh, maybe we can just create a little formula for that. But actually that's much more difficult to do than you would imagine, because each boat is different and they react to all the conditions in the wind and the water in its own unique way. And also the situation under which a boat starts to foil, that's also unique, and that's not so easy to capture in one simple formula. So how can we solve this? How can we find the relationship between wind angle, wind speed, and boat speed? For that, we're going to use machine learning. So you see this table here on the left hand side, and imagine we've gone onto the water and we've made measurements while we were on the water. So at some point there's a certain wind speed, we choose to take a certain angle to the wind, and that resulted in a certain boat speed. So that's one measurement. And then like that we can do many measurements, hundreds of measurements. Now with that measurement we can train a machine learning model. So this goes into a training algorithm, and we're going to use AutoML to do this. And the result of that is the model. Okay, so let's imagine we have the model. So the model can tell us, given a certain wind angle and wind speed, what would be the resulting boat speed, right? So we go to this prediction phase. Imagine we're now on the water, and of course then we have a certain wind speed, that's kind of a given. Then we can ask this model, okay, let's say I would take a wind angle of 41 degrees. What would be the resulting boat speed? And we would get that prediction. Or what would be, given this same wind speed, the result if I choose a wind angle of 42? Well, then you get a resulting boat speed of 30 something, right? And like this we can do this for a range of angles, and then the sailor can make an educated choice of which angle he's going to choose to get the fastest possible boat speed. Okay, so let's get into this and let's go to MySQL. So here I'm already logged into the MySQL client, and let me just show you the contents of this table. So that table with the measurements, okay, that's in SailGP, SGP, Sail History. And I'm doing something wrong here. Yeah, select star from, there we go. So we just see the first 10 records here, and you see it's these combinations of wind angle, wind speed, and the resulting boat speed. So this is really good material to train a machine learning model. So that's going to be our next step. And I'm just copying the command here. I'm going to run that straight away and then explain it to you. So what we're doing here is using AutoML, right? So we're not specifying what is the kind of machine learning algorithm that needs to be used. Instead, that's going to be automatically determined for us using AutoML. So this means that also people that don't know exactly about all the algorithms that are available, they can still use this, excuse me, because the AutoML will choose the best possible algorithm that leads to the highest accuracy. Okay, so what are the parameters here that we're using? So we're calling sys.mltrain. We see this is the input table with our measurements, which we just looked at. This is the target, the output variable, the things that we want to be predicting later. And then also, there's one more thing here that's important. So by default, it will try to find a relationship between all the other columns in the table. So all the other columns apart from boat speed. And the problem is there's also a PK column for a primary key in that table. So we're just saying here, don't use that PK table, just use the other columns. Okay, so that's done. And yeah, in 1 minute and 20 seconds, we now have a model under the name boat speed model. Okay, so let's have a look at that model. And for that, I'm going here to the model catalog, and we see indeed we've got a new model. The algorithm used is XGB regressor. Okay, so apparently that's leading to the highest accuracy. The input variables, we already knew that. That's wind angle and wind speed, and the target column is boat speed. So we've got a model. Now we can start to make some predictions. Okay. Now I could make just one prediction at a time for one combination of wind angle and wind speed, but instead we're going to do this for a whole range of wind angles. Okay, so I've got this table here. I'm going to show you the contents. Let me see again, let's do limit 5 or something. So this is very simple table. We have wind angles of 1 to 360. And for one particular wind speed, we want to be able to predict all of the boat speeds, the resulting boat speeds for that. So actually, let me do this without the limit. So for example here, we do this in steps, right? So for wind speed 25, we calculate, or we predict all of the resulting boat speeds from 1 degree to 360 degrees. And we do the same thing for, let me see, for 20 knots of wind speed, right? Again, all the angles of 1 to 360 degrees. And then for 15 and for 10 and 5, etc. Okay? So this is just a simple placeholder table. And now we're gonna call the predictions on that table, right? So how do we do that? We load the model first with this command. So sys.ml model load. And then it's time for the predictions. So how does that look? We use sys.ml predict table. The source table here is that one that I just showed you. We're using our model, and we're also saying this is the target table that all the results should go to. Okay, so if we just execute that, that's actually really fast. It's just less than 2 seconds here. And now we can have a look at what is in this table. So if I say, okay, select. So I'm asking now for one particular wind angle and wind speed, what the prediction was. So we see here wind angle 45, wind speed 10, then the predicted boat speed is 17 knots. So you think, yeah, that looks pretty good. Let's see if we can visualize this now in OAC and if we can put this in the hands of a sailor. So let's go to OAC. Okay, and now we're going to go to that data set that we just created, which is this one here, RGB boat speed predicted. And here you see the input wind angle, the wind speed, and the prediction that comes from our model. So let's see what happens if we visualize that. I'm just gonna change this to a line diagram. Right, so on the horizontal axis we've got wind angle, on the vertical axis we've got prediction. What can we do with this chart now? What use is this for the sailor? Well, the sailor can now, for example, look for the highest point here for wind speed 5, and he can see, okay, so the predicted boat speed here is with a wind angle of 95, I would get a boat speed of 10.57 knots. Okay, so it looks pretty good. With that, can the sailor now make an educated choice of which angle to take? Well, not yet, because we're not quite done yet. And let me just take you back to a presentation to explain what we're still missing. So if you think about it, what we just calculated here are these green lines, or I say calculated, I mean predicted. And based on the wind angle and the wind speed, we get the length of these green lines, right? But that's not really what we want. What we really want are these lines, these purple lines. Because the green line indicates the boat speed, but the purple line shows us how much progress we're actually making towards the target, into the wind in this case. So how can we get the value of the purple line? Well, if you remember a little bit about high school and the subject of trigonometry, you know we can calculate these things with cosine. So do we have to use this now? Do we have to create a calculation for that? The answer is no, because we can actually do a visual trick in OAC that will do this implicitly for us. So let's go back to OAC. And now I'm going to change the type of chart here. So I'm going to change it from line to radar. And that means it's going to be displayed in a circular shape. And look at what's on the edge of the circle. These are now the angles to the wind from 0 to 360. Isn't that a nice natural way of showing the angles? And the distance from the origin here to whatever point you take here on the line, that is the speed of the boat. So here we see in this region very high speeds, for example. And the thing that we're looking for, that's now been done for us, is the vertical distance from the origin here, from this line, the horizontal line, up to the point of interest. That indicates the speed of the progress towards the goal. So that is our purple line from the chart. So how can we use this now? Well, for example, I'm looking at a wind speed of 10. Well, then I want to find the highest possible speed towards the target, right? So for that I find the highest possible vertical point, which is, I think, about here. And that tells me that at wind speed 10, if I take an angle of 55 degrees to the wind, my boat speed will be 21.8, but actually that's not so interesting. The interesting thing is that I can get 14 knots towards the goal, which is the highest possible for this wind speed, right? So now we actually have an answer for this sailor, and he can pick this particular angle in these conditions. So let's do one more. Let's say the wind speed is 25 knots. And again, with this green line, I'm going to look for the highest point. I think it's here. And this basically tells me, the highest possible speed towards the target would be reached if I take an angle to the wind of 49 degrees, at which we would, we reach a speed towards the target of about 24 knots, I think I estimate here. So again, we can help the sailor now, and he can make a really educated pick of which angle he takes to the wind. So that solves our challenge. Okay, so let's summarize that. We started by building a machine learning model using the AutoML feature of MySQL HeatWave. Then still in MySQL HeatWave, we did like a batch prediction for many different combinations of wind angles and wind speed. And then finally, in OAC, we displayed the result of those predictions in a very smart way, in a circular way, so we could see exactly what is the resulting speed towards the target, and we let the sailor choose the best possible angle so we can reach that destination as fast as possible. Okay, so yeah, we've covered quite a lot in this session, I think. We've looked at data loading, and especially using the Lakehouse functionality, so using object storage. We've looked at visualization, we've looked at machine learning, and yeah, these are exactly the kind of activities that you'll see time and time again when you work on analytical challenges. So I hope this helps you, and that it maybe also inspires you to work on your own challenge with MySQL HeatWave Lakehouse. Okay, just to come back on what I already mentioned in the beginning, it's possible for you to try out MySQL HeatWave Lakehouse yourself. We've got this live lab, so this is like a workshop, and you find all the instructions there that you need to reproduce the exact same thing that we did today. So all the steps are in there. Also how to get an OCI trial and how to provision all of these services. Now, and last of all, I recommend you have a look at these upcoming events for SailGP. Maybe a chance for you to visit one of these, and for sure you will see spectacular action on the water. Thank you very much.